Right, so continuing our work then on proof. The proofs we've done so far have been entirely algebraic because ultimately we're trying to prove things about numbers. If you want to write down numbers in general, if you want to write down any number, then you write down a letter, okay, because that letter will represent a number. We're moving on now to any proof that involves shapes. You've seen some already, or at least the building blocks of proof. You've seen questions that might involve angles, and when I say it's a proof, that's because you give reasons, don't you, as you go along. So you might say this particular angle is 50 because alternate angles, that kind of thing. So that's sort of proofy because you're sort of justifying as you go along, you're giving reasons. I also showed you there's like a special way of writing proofs where you use the upside down triangle for because. Okay, hopefully that rings a bell. We have studied congruent triangles already. They would be proofs as well, involving shapes, so that would be a geometric proof. I don't think any of the questions I've set involve congruent triangles, but if there is one in there, it doesn't hurt you at all because it certainly is something that we've covered. We've recently looked at vectors and vector proofs. I won't go back through those, but there are of course certain things that we prove, like things are in a straight line and midpoints and stuff like that. And we've seen circle theorems. Not very many of them involve proofs. They can. You can be asked, prove the alternate segment theorem, or prove that the opposite angles in a cyclic quadrilateral add to 180. So you could be asked to prove them. I think that would be a little bit too tricky during lockdown. So I think that's something we ought to revisit because you were good at circle theorems. I was impressed with the work that was submitted, especially the hard ones as well. But actually proving them, the logic, I think that will probably require a lesson when we return. What we'll really be looking today is that when I give you a particular picture, sometimes there's a relationship between some of the angles, like maybe one of the angles is twice the other one, or maybe one of the angles is 180 minus another one, that kind of thing. So that's the type of question we'll focus on mainly, proving relationships that are asked for. Perhaps the easiest way is if I just shut up and show you some examples. Hopefully they'll be sufficient to give you a clue how the questions work. Okay, so here's an example then. It's one that I found in a book. This is just a basic angle one, so I'm starting with something we should be familiar with. Just a reminder then, capital letters are always points on the picture. So E refers to the end of this line, for example, and the F is where all those lines meet there. So capital letters are always points. You might come across little like tick marks that would mean the same length. Haven't got any of those on here, but these arrows mean parallel. These lines are going in the same direction. If you infinitely extended them, they'd never meet. And then if you want to describe a particular angle, you need 3 letters, and you put this little hat in the middle. So find angle BFC, that's this one in here. I want to know how big that angle is there. There's lots of different ways of doing this question. However you do it, you must justify it as you go along. So for example, maybe the first thing I notice is that these two are alternate angles. Okay, so I could start by saying FBC is 70 because alternate. Okay, it's alternate to the given EFB. So I can put that in now. That's 70. And then I could do this is now in a triangle, isn't it? The angle that they're asking us for, the BFC, this one here, is in a triangle. So I could just do 180 minus. So let's do BFC is 180 minus the 70 and the 50. That's 180 take 120. So I get 60. It's my final answer. But what was the rule I used? I used angles in a triangle add to 180. Okay, because it's a little bit tedious, but you have to write it. Angles in a triangle add to 180. If you want to use the posh word, don't have to, but the English adjective for add to 180 or adds to 180 is supplementary. So you could have said angles in a triangle are supplementary if you really wanted to. I think most students prefer to stick with what they know, especially in the pressure of an exam situation. You can just do it in English, that's fine. Okay, this upside down triangle of course means because. If I put it the other way up, it means therefore. I might be doing that as we go along, we shall see. So that one's finished. This is a sort of angle proof type question. I've given reasons as I go along. That should be familiar to you, but the next one I found in a book, and it reminded me strongly of this just this GCSE question. So you can see how they're related. I thought it'd be worth doing this one first. Okay, so maybe you're looking at this and thinking, Mr. Friend, that's nothing like the other one. To me, it's incredibly similar. I think the setup is much the same. But what we've got here then is we've got an angle given, I don't know what it is, but the angle up here is twice as big. So if, for example, that was 40, then this is 80. We don't know exactly what it is, but we've got this sort of double relationship here, and there's another angle in there. And what we're asked to show is that if you do, 3 times this angle and you add y, you get 180. Okay, there's quite a lot of different ways of doing it. I notice, for example, maybe you've got a different way, but I noticed that this one and this one are alternate angles. Okay, so maybe that's where I'll start. I'll say BDE is 2x. So it's a bit like I was doing before, but it's just got algebra in it. So I don't really think there's much difference, it's just got algebra in it. So BDE is 2x, and the reason for that is alternate. Right, and now I'm going to add these together. I'm going to say that maybe I'll do it with 3 letters first to be really, really super clear. This might be overkill. So the CDA plus the ADB plus the BDE, which I just worked out, that equals 180, and the reason for that is they're on a straight line. Okay, angles on a straight line are supplementary. So because angles on a straight line add to 180. Now if I restate this again, but this time of what they are, because I know CDA is called x, so this is x plus y, so the ADB is y, and the BDE is 2x, equals 180. And then I've got, if I just collect like terms, x plus 2x is 3x. And I'm done. So really the only geometry there was one, well, there's 2 things I suppose, wasn't it? We did alternate angles and angles on a straight line add to 180. That was pretty much all we needed. I like to finish this with as required. Other people go with QED. Up to you, don't mind. You choose your own favourite way of ending proofs. I'll show you one more example. Okay, now in this situation, all sorts of things going on. I've got a whole load of points, the A, B, C, D, they're all points in the diagram. This time I've got these tick marks I was talking about earlier. They don't have to be doubled up, you could have just one of these, but that means same length. So it's telling me that CB is the same length as DB. And I may or may not need this yet, but that would make this an isosceles triangle, wouldn't it? Because if a triangle has 2 lengths the same as isosceles, I might need that in a minute, I'm not sure at this stage. We've also got parallel lines going on, so I can use my things like alternate and corresponding if I really want to, or co-interior if that comes up, but that's kind of useful. Things like opposite angles are going on here. But anyway, let's have a go at the question. What are we asked to do? Prove that the ABC, so where's the AB? That's this one. Prove that ABC is the same size as ABF. That's this one here. So basically prove that these 2 are the same. That's what I've got to do. And I've got one angle given. This one here is marked as A. Let's just go ahead and see what happens. I mean, I'm not completely convinced what's going to happen yet, but let's just see. I will use the isosceles thing, I think. There's no harm in writing stuff down. If I write stuff down that I don't end up using, it doesn't matter. It's better to stick down things that you think are probably true, and then you may or may not need them by the end. So I noticed this one is the same as this one because isosceles, okay? And I could even say, let's be belt and braces about it. So CB is given as the same length as DB. We'll say therefore triangle CDB is isosceles. Okay, so now I know that I can use the fact that the angles will be the same as well. So I can say that angle CDB equals A as well. That's also A, because isosceles. See, that's my therefore, and that's my because. Cool. I can work out this missing angle if I want to in the triangle, because I can still 180 minus the others. Well, these two together would be 2A, so I could say that angle DBC equals 180 minus 2A. And you might think, well, what's that? It doesn't matter, it's just an expression. You can just keep the expression. There's nothing wrong with that. And the reason for that is because angles in a triangle. Add to 180. Okay, good. Well, this would be the same as well. Okay, so I've just found out this one here is 180 minus 2A. This one here I'm going to claim is also 180 minus 2A. The reason for that is they're opposite angles. So let's say then that FBE is also 180 minus 2A. Just the same thing as what this one was, because opposite. Like I said, I don't know if I'm going to use all these things yet. I'm just writing things down that I know and the reason why I know them to be true. This one I've got actually, right? Notice that this one and this one are alternate angles. Okay, so I'm going to put that one in there as well. So I've got, what's that one called? ABC? That's good, that's one of the ones we need, isn't it? So ABC is A, because alternate. All right, alternate to the given one. So I suppose I really want this one now to be A, don't I? It might be worth saying at this stage, I don't know what this one is. All right, let's try to complete the. I think I just about have enough space left. I'm now going to say I want this to be A, but I'm not sure yet if it is. So let's say this is mystery. So ABF. Let that be called X, and I'm hoping that X is just A. I'm hoping to establish X equals A, because what I do know is that this is a straight line now. That one, and that one is a straight line. Maybe I'll be able to rearrange it or something. Let's have a look. So I've got then that A plus X plus the 180 minus 2A equals 180, because angles on a straight line. To 180, which is good. I suppose I could have written this with 3 letters first if I wanted to, so that would have been the statement ABC plus ABF plus FBE equals 180. I could have done that first if I wanted to, but I think it's clear enough, to be honest, given that they've told us the A and I've introduced this thing called X. I think that's clear enough as it is. Let's sort this out. Well, look what we've got here. We've got the brackets aren't actually doing anything here. I've got A take away 2A, so that's X minus A. So X leaving on its own. A take away 2A is minus 1A. I've got plus 180 here, and that's equal to 180 on the other side. I think I'll just about get this in, won't I, if I just shift that up a little bit. What I'm now going to do is take 180 from both sides, so that gives me X minus A equals nothing, and then I'll add A to both sides, X equals A. Brilliant. So I'm done, and to make that really, really clear, who was X? Well, X was ABF, and A is a few different things, like A was this one, and it was this one, but most importantly it's this one, ABC. And that is what I was trying to prove up here, wasn't it? That was what it is. Okay, it's written back to front. The left is on the right and the right is on the left. But that is what I was trying to prove. So I have finished, and I can put my QED in here, and I'm done. I might have slightly over-egged that. But the basic idea in all of these questions is just start writing down stuff that you know. And you might not even end up using all of those things. But no sweat, it doesn't matter. Just go for it. Just write down things. And I don't know if you realised or not, I really wasn't cheating, I promise you. I just started doing that question without having any idea whether I was going to get to the finish line or not. I didn't have a sort of concept of what the whole proof was going to look like before I started doing it. I just started writing things down, and eventually I was like, oh, look at that, and it just dropped out in the end. You need to have a similar sort of confidence where you just try stuff, and if you don't get to the end, no bother, because if you've written something that's correct, there's every chance you'll get an odd mark, even if you don't get full marks. So that's what I'll be looking for when you do send me your photos and so on of your work. I'll just be looking that you've tried some vaguely sensible stuff. Okay, that's really all I'm looking for. Right, well, best of luck with these.